Hello everybody, this is Mr. Chow again. Let's recap what you learned last time. In part 1 of chapter 11.7, we did the proof of these two trig code identities and some examples related to this. Today, we are going to use this again and do some different types of questions. Let's begin. The first example, and there are two parts in this. For part A, rewrite tangent square theta in terms of cosine theta only. Now, when you see tangent theta, remember, as I said before, you need to change tangent to sine over cosine. Therefore, tangent square theta is equals to sine square theta over cosine square theta. Now you can see the denominator is cosine square theta already. That means I just need to change sine square to cosine. It's okay. If you still remember, there are two other forms for the second trig code identity. That is, when you see sine square theta, you can change it to 1 minus cosine square theta. Now check the numerator, denominator. All of them are in terms of cosine square theta. Done. Let's go to part B. Given that cosine theta equals to 0.2, find the value of 3 tangent square theta without finding theta. Have we done this question type before? Yes, in chapter 11.6, you have done that. But so funny, why do we need to do it here again? Because we are going to learn a new method to solve this problem. Let's see. Okay, we want to find out the value of 3 tangent square theta. And in part A, we got tangent square theta equals to 1 minus cosine square over cosine square. Then I just copy it. Okay? I just copy it. Now, given that cosine theta equals to 0.2, then simply by substitution, just put 0.2 into cosine theta. And remember to take square for them. And then by using the calculator, you can get the value be 72. Done. Now, you may ask, can I use the method mentioned in 11.6? I'm going to show you in the next example. Let's go. Now, given that tangent theta equals to 0.4, find the value of, this one, 4 sine theta over cosine theta minus sine theta without finding theta again. Again, try to pause the video and then you use your own way to do it first. Then you come back and then see the two methods. I'm now going to use two different ways to solve this problem. For method 1, that is the method mentioned in chapter 11.6, that is by using a right-angled triangle, that one. First of all, tangent theta equals to 0.4, then I rewrite it into fraction form, so that I can identify the two sides easily. Now I draw a right-angled triangle with right angle with theta. By definition of tangent, okay, tangent equals to O over A, therefore opposite side is 2, and then adjacent side is 5, just the ratio only. Okay, you can let them be multiples of 2 and 5. Now I let the hypotenuse be A. Then we can find out the hypotenuse by using the Pythagoras theorem. That is this one. And remember to state the reason after it. Now you will get A equals to root 29. As we got the hypotenuse, then we can find out the value of sine theta and cosine theta. Okay, again, by definition, sine theta equals to O over A. That means opposite side is 2 and then over hypotenuse. And then cosine theta equals the adjacent side, which is 5 over root 29. Therefore, what I do next is substitute the values of sine theta and cosine theta into this expression to get this line. Then simplify numerator, simplify denominator, and you can get this one. And now you can see we can cancel out root 29. Therefore, the answer is 8 over 3. Done. Now, on the right hand side, I'm going to show you the second method. That is the method I used in the previous example. The key for the second method is try to convert all these trickle ratios into the given trickle ratios. In this case, you need to change the sine, cosine theta to tangent theta because tangent theta, the value of tangent theta is given. By using this method, we don't need to know the value of sine theta and cosine theta. But now you may want to ask, oh, Mr. Chow, I didn't learn any formula to change sine, cosine to tangent. How can I solve this problem? Give you some tips. The tips is you can use this identity. Sine over cosine equals tangent. The textbook will tell you, you can change sine theta the subject. That means sine theta equals to cosine theta times tangent theta, and then substitute sine theta in it. You can get a value. And I'm going to tell you my method. I will still use this identity. Now, let's think about it. If I don't want to change the value of this one, what can we do? We can multiply a certain number to both numerator and denominator, right? But we can also divide something to it. Now, I look at this identity, sine over cosine. If I want to change it to cosine, that means for the numerator, I simply divide it by cosine theta. Then I can get tangent theta. If I want to divide cosine theta to the numerator, I also need to divide cosine theta to the denominator. That is this one. Then for the numerator, sine over cosine equals tangent. Therefore, I got 4 tangent theta. In the numerator, how about the denominator? Cosine over cosine, okay, it becomes 1. And then minus sine over cosine again, then minus tangent theta. Oh, we have done. As we have changed everything from sine, cosine to tangent already. As we know the value of tangent theta is 0.4, it is given. Then next one, just do it by substitution. And then by calculator, you can also get 8 over 3. Done. And for the final answer, some of you may get 2.67 and then correct to 3 significant figures when you use the calculator. But this answer is not accepted. Not accepted. Because if you can give the answer in exact values, then we can't give the approximate answers. Then you may ask, which method is better? I would say method 2 is faster. But you cannot apply method 2 to all questions because sometimes it's impossible for us to change the whole expression to the given ratio. If it happens, we must use method 1. Therefore, learn both methods. For the previous 2 examples, you may put them into the first question type. And now, let's go to the second question type. Solve some trickle equations. Okay, look at this one. With the using a calculator, solve 4 cosine theta minus 3 sine theta equals sine theta. Have you learned how to solve trickle equations before? Yes. In 11.2 to 11.4, you have solved some trickle equations. I gave you some examples. Look at the right hand side. If sine theta equals to 2 over 3, how to get theta? You can get theta by typing shift sine 2 over 3 in your calculator. Then you will get theta equals to 41.8 degrees. And then correct to 3 significant figures, right? One more example. How about if cosine theta equals to 1 over 2? Without using a calculator. If you remember the 9 values for the 3 special angles, you will get theta equals to 60 degrees. Because cosine 60 equals to 1 over 2. You must remember the 9 special values, okay? By looking at these 2 examples, you can see the key. That is, if I can change it to this form, that is a trickle ratio equals to a value, then I can get it by calculator. Now, go back to this question first. Now, I copy the question first, then I move negative 3 sine theta to the right hand side. And remind you that this is 1 sine theta, therefore 1 plus 3 equals 4. Next, we can cancel 4 on both sides so that we can get cosine theta equals to sine theta. Now I put a remark here. as many students will stop here. Jot down this technique and remember it. Okay, now what's our target? We want to change it to 1 trickle ratio equals the value, right? Look at the 2 stars on the right hand side. But how? We got cosine, we got sine. The key is by using identity 1. That is using sine over cosine equals tangent. Now I can divide both sides by cosine theta, just like solving equations. Okay, what's the right hand side? Cosine over cosine so that you can get 1. How about right hand side? Sine over cosine so that you can get tangent theta. Now let's look at the questions again. I highlight this one without using a calculator, and you are now going to solve the trickle equations, right? If you see these two, you need to think of the special angles. That means the answer must be the 3 special angles, 30, 45, or 16. Now tangent what equals 1? Yes, theta equals to 45 degrees, because tangent 45 equals 1. Done. Again, there are some reminders. The first one, don't miss the unit degrees, as theta is the angle. The second one, how to check the answers. Not looking at the answer key. You can substitute this one into the original equation to see if left hand side equals right hand side. If yes, then your answer is correct. Now, the last question type in this video. Prove identities. Now look at this one. Prove that this one equals to cosine square theta. And what you need to pay attention is remember the format of proving identities. First, let's start from the left hand side. Okay, I write down LHS and then equals, copy the left hand side of the identity first. And just like what you did before, when I see tangent, I change it to sine over cosine. Now you can see we can cancel out cosine theta. And cancel out one of the sine theta, you will get 1 minus sine square theta. And I hope you have built a good sense that 1 minus sine square, it equals to cosine square theta. And therefore equals to right hand side. The last step, draw the conclusion, write down, therefore it is an identity, or you can copy the whole identity once, up to you. In the last part of the video, I'm going to give you some special question types which are not covered in your homework and give you some reminders. The first one, find out the value of sine square 41 degrees plus cosine square 41 degrees. If you look at all the questions that you did before, you will see the angles are all theta, but not the exact values. Without using a calculator, I can get the value be 1. Why? Because of the identity on the right hand side, sine square theta plus cosine square theta equals 1. Please be reminded that the two angles theta here must be the same. That means if the first one is 41, the second one is also 41 degrees. Therefore, if I want to find the value of sine square 42 degrees plus cosine square 41 degrees, it is not equal to 1 because the two angles are not equal. Then, can I apply the same concept to the first identity, sine over cosine equals tangent? Yes, we can. For example, look at the first one, sine 68 degrees over cosine 68 degrees. You can change it to tangent 68 degrees because the two angles are equal. Look at this line. If the two angles are not equal, one is 72, one is 35 degrees, you cannot change it to tangent 72 or tangent 35 degrees. The last one, students will make mistakes to simplify sine theta over tangent theta. If you are not familiar to change this one, try to rewrite it into this form. Sine theta and divide, you change tangent to sine over cosine. Next, you can change divide to times and then reverse sine theta and cosine theta for the second part. Now you can see we can cancel out sine theta. So it becomes cosine theta. Done. Then how about cosine theta divides tangent theta? By using the same method, we write it into cosine theta divides, change tangent to sine over cosine, and then after that, change it to times cosine over sine. Now you can now see we cannot cancel cosine theta because both of them are on the upper part. Therefore, you can simply multiply them to get cosine squared theta over sine theta. And also, you can change cosine squared to 1 minus sine squared theta. Finally, just want to share with you something. I just watched my last video and I found that my handwriting was too bad. Because it's not easy for me to write down something on the iPad. I will try to improve it. At least I will make it clear. See you next time. Goodbye.